Well, once again, pre-calc classes, good morning, good afternoon, or good evening. I know nowadays that may be a little different for everybody out there watching this. So, we are going to finish up the last half of 5.3's notes. They're actually very short, kind of with all of the other 5.2 and 5.3 formulas. You do not need to worry about memorizing anything. And what we're going to go over is actually an alternative method to something we looked at in 5.2 with your sum and difference formula. So if you happen to have that sheet handy, you may want to hit pause and grab that real quick. We will also be using a unit circle a little bit as well. So if you have one of those handy, that would probably be useful too. So when we start talking about our half-angle formulas, there are three of them, one for sine, one for cosine, and one for tangent. The sine of theta over 2 is plus or minus square root 1 minus cosine theta over 2. For cosine of theta over 2, it is also plus minus or positive and negative square root 1 plus cosine theta over 2. So you can see between the two formulas there is just a very small difference. And then tangent, well, tangent is sine over cosine. So if we take this radical over this radical, well, what ends up happening? The 2's cancel, and all you have is the square root of 1 minus cosine theta over 1 plus cosine of theta. Now, as you see, they all have a plus or a minus. Well, that is determined by the quadrant of the angle that you're working with. So, for example 1, and this is actually the only example we use for the half angles, we're going to find the sine of 105 degrees. Well, as I mentioned, we're going to compare to some of the sum and difference questions. Well, one way of looking at this was we treated the sine of 105 as 60 plus 45 degrees. Another way that you can actually use a formula to find the sine of 105 is to use the value on the unit circle that 105 is half of. Well, the sine of 105 degrees is the same thing as saying the sine of 210 degrees over 2. So when we talk about theta, we are going to use theta as 210. So what ends up happening when we actually set up our formula? Well, it says plus or minus. Now, we'll talk about whether we need positive or negative here in a moment. And then square root 1 minus cosine 210 over 2. All right, now is where we're going to actually talk a little bit about whether it's positive or negative. Well, the sine of 105 degrees is right here in quadrant 2. Well, knowing that sine is our y value, in quadrant 2 our y values are positive. So of the plus or minus, we need positive. If we were actually working with the cosine of 105, that's where you would actually take the negative, because in quadrant 2, cosine would have been negative. So that's kind of a way to mention whether it's positive, whether it's negative. So we're going to use positive square root 1 minus, now, here's where our unit circle is going to come back into play, the cosine of 210 degrees. 210 is right here. Cosine is our x value, so we are going to use negative radical 3 over 2. All right, so as far as what happens from here, I am going to make this 1 over 1, and then we are going to need to get a common denominator. So this becomes the square root of 2 plus radical 3 over 2 all over 2. Now I know for our essentially final step, although there is one last step where we can actually simplify a little bit, but when you have a fraction over a fraction, that is where we are going to multiply by the reciprocal. And so when we do that, we now end up with 2 plus radical 3 over 4. So once you get here, we are essentially finished. The only other thing that we can actually do, because you are taking both the square root of the numerator and the denominator, this gives us in our numerator the square root of 2 plus the square root of 3, which I know is a little bit unusual. You can actually have a square root within another square root, and then the square root of 4 is 2. Because we are able to eliminate that radical in the denominator, we want to go ahead and do that. So you can see this answer is a little bit different than what we came up with the other day. Now there are some similarities with this. If you notice, here we have a square root of 2. Here we also have square root of 2. Now the one thing that is a little different, because you now have a square root within it, square root of 6 here, that's where this square root of 3 within the radical comes from. And again, here we have a 4. There, the square root of that 4 is 2. So you can see it is a little different method for coming up with a similar solution. So half angle formulas is where you are taking the unit circle value divided by 2 to get 105. A sum or a difference formula, we are using two angles that would either add or subtract to 105 degrees. Once again, with section 5.3, much like section 5.2, those assignments are included on Pearson. But you guys can now certainly work through both of the 5.3 assignments.